We are going to differentiate this function. We're going to differentiate the function using some of the rules that we learned. Now we have to be very careful, because if we're using the rules and we're not going back and using the limit definition of derivative, we can't use the properties of limits. So if I was using the limit definition and I had this quotient, I could take the limit of each term, and I could take the limit of the numerator and the limit of the denominator and then divide them. However, if I'm using rules, I don't know that the derivative of the numerator divided by the derivative of the denominator is this derivative. In fact, it's not. We will learn that in a later section when we learn the quotient rule. So we need to be careful about what we can use. We know we have the power rule. We did also establish that when you have a sum or difference, you can differentiate each term and then add them or subtract them. But that will not be true about the quotient. So if I want this derivative, the first thing I'm going to need to do is some algebra on this so that I can express this as just a sum with some different terms in it and get rid of the quotient. So I am going to actually apply that denominator to each term like this. And then I'm going to express each of those as a term with just one x to some power, and then I can use the power rule on that, and then I can take the derivative of each term and then sum them together. So looking at the first one, this is x to the 2 minus 1/2, because we know the square root of x is x to the 1/2. So 4 halves minus 1/2 is 3 halves. So this one is x to the 3 halves. And then we have plus, so this one is x to the 1 minus 1/2, so 2 halves minus 1/2. We have the 4 out in front, and then x to the 1/2. And then the final one can be expressed as 3x to the minus 1/2, because this was in the denominator to the 1/2 power. Now I have this expressed as a sum, and I can, to find the derivative, differentiate each term. So this first one's going to be a power rule. Power out in front. Decrease the power by 1. 3 halves minus 1, which is 2 halves, would leave us 1/2. Plus, okay, I can multiply the constant and then do the power out in front. Decrease the power by 1. 1/2 minus 1 would leave me a minus 1/2. And then constant, and then go ahead and do the power rule, power out in front. Decrease the power by 1, so I'd have minus 1/2 minus 2 halves, which is minus 3 halves. Okay, let's see what we can do to simplify this, and we're going to put it back in radical form. So this is 3 halves square root of x. Next one is plus 2 over square root of x, because there's a minus right here. So we would move that down and then express it in radical form. And then we have minus 3 over 2 square root of x to the third. Last thing to do, this will actually simplify because I can bring an x out in front. So I would have 3 halves square root of x plus 2 over square root of x minus 3 over 2, x out in front, square root of x left under.